Check 1 2. I hope you can hear me. I hope everybody can hear me. Hello, this is Todd from Dr. Canuro's class. I guess we're team one, guys. I started on the project that Dr. Canuro wanted us to do. I kind of switched it up a little, trying to get a little fancy, and I used dryer vent. And part of the instructions for the class was sorry, I have Tourette's. Sorry about that, folks. Part of the instructions for the class was to put a line, like an access for a line. Okay, I'm going to use that as the arch, you know, the arch of the line. And I haven't made, like, black lines to show where it divided, but of course, the dryer vent has the lines, in case you can see. So, what I'm going to do, this is a straight piece. I stretch it out to the total length it's going to be, okay? So the total length it's going to be is stretched out. So I'm going to point this black part towards you, the center line, to show you guys what happens, okay? So I bend this into an arch, okay? And I'm going to stretch it out a little bit, right? I bend it into an arch, right? Now, from the looks of things, the arch got a little shorter, but I don't think that's really how it will work. You guys can figure that out for discussion. The arch got a little shorter, but I think in the module it showed that the arch would stay the same length, but that's because, you know, we've compacted it. So if you stretch it out, it'll be the same length, see? So the middle arch, the, what do they call it, the base axis or whatever, is the same. Now something I want to show you guys, if you'll notice, when this is straight, the lines are straight. See the lines? They're straight, right? Now when I curve it, what happens to the lines? You'll notice, of course, the way the dryer vent's set up, the top stays the same, but this bottom part, see it right there? Narrows out. Let me show you. The bottom part narrows out, see? The bottom part narrows out and the top widens out. So that's a topic for discussion. Now the other thing that I know about anything about bridges and stuff like that, and angles and slopes, is that's actually a slope, a curved slope. So what you're really going to do is go to the peak of the bridge, right there, and start a right angle. This is a drafting protractor. But you start a right angle, either way, either that way or this way, at the peak of the bridge. And this curved part right here, as you can see, is your hypotenuse. So this is your y-axis, this is your x-axis, or this is your y-axis, this is your x-axis. I don't think there'd be a negative or a positive x or y-axis, because it's just reverse of each other. You know, you got one side of the bridge or the other, which is pretty much the same. I don't think they'd make a bridge with two different ends, but arch bridge. But anyway, so this is your y-axis, this is your x-axis. So all of your equations can be angles this way, okay? Now, I don't think you take the curve into consideration like you would throwing a ball in acceleration formula, because you don't really have to, I don't think. But there is a curve here. So this is basically the hypotenuse of the bridge, right? The bridge, when it comes down, that's your hypotenuse, you know, x and y. That's your hypotenuse of the right triangle, A, B, C. So when you're doing this formula, you need to take these angles right here of all these individual bridge parts as if you were creating a bridge to compose the whole bridge. So each of these angles here, let's say they weren't compacted at the bottom. You know, we could talk about that. Does the angle narrow at the bottom when the top opens wider? How does that work? And does the tape get shorter? Does the line get shorter? I think in the study in our coursework, it shows that the length stays the same, which I imagine it does. I don't imagine they'd start a bridge and measure it as you know, 500 feet across the canal and have to have you know 6,000 feet of material. I think it is what it is. But then again, yeah, but you have to consider that the arch. So anyway, this is what you're measuring: is all these little things here. See, 1, 2. All these little things are different angles to the hypotenuse. You know. So really, if you were going to measure those angles, as we've learned in class, you kind of got to bend it, let's see, like that, to do your hypotenuse, you know, to do your x and y axis. Bend it like that according to the angle. Now another thing you'll notice is, like I said, it compacts at the bottom and widens at the top, correct? So this angle changes too. You got the wide angle up here and the low angle down here. So that's what we're going to be taking into consideration when you make an arch bridge. So that's up for discussion. I guess the discussion is, does the middle line get longer or shorter when you bend the bridge? Would the engineers, when they designed the bridge, have to account for more material for the bridge if they're making an arch bridge if they would a straight bridge? And in real life, when they're making a bridge, does the bottom angle, is that bottom angle smaller than the top angle? So if we were going to measure a bridge, we can't compact it, right? We can't compact it. Just go like this. Okay, that's how much we need. If we were going to do, just be the parts people for the bridge, the engineers ordering the parts, you'd have to go to the top angle of the bridge and say, okay, how much angle are we going to need? And we're going to need this much material, correct? I mean, that's for discussion. So this is what we're doing, guys, and I hope Dr. Kanura is fine with this. I didn't use a piece of, what do you call it, pool noodle, because you can't find them this time of year up north. There's no pool noodles. I don't have any, and there's none at the stores. It's winter time. It's 30 degrees out, 20 degrees out. So, but this is the question. So I got some dryer vent, and I think that would explain more what we have here. I'm going to show you up close what we have here. See the angles? Now look, the bottom angles is less of a slope than the top angles. Why is that? And of course, this looks like it shrunk, but it's still the same size. If we kept it out the normal size, it'd be fine. So that's the questions I must ask. Would an engineer need to buy the material based on the top side of the bridge or the bottom side of the bridge? And would the bottom side of the bridge be just considered a straight bridge? And the top side of the bridge have to be accounted for the angle of the bridge. And that's the questions I ask you guys. So let's go over this with Dr. Kanuro and do this together, and we'll figure this out. Nice talking to you guys.